Good morning, everyone, and welcome you all in my lecture series of my course Engineering Thermodynamics. In my previous class, I have completed the introduction to the work and heat. Before I go for the further solving of some problems related to the work and heat for the pure simple substances, we should also understand how we can see the steam table and what is the use of the steam table. We have seen till now in our so many lectures that we are using the water. This initially the water was used to convert this heat into work. From the James Watt, the person who has made the first steam engine, he has started heating the water and he got the steam, and this steam he has stored in a boiler, and this steam was fed to the reciprocating engine, and by that the locomotion first train was started by the steam engines. So many boilers, ships, and so many places these steam engines were used. However, the efficiency of these steam engines were not so good, and slowly in the next decade, next century, the internal combustion engine came into play, and these internal combustion engines were very much used for all type of propulsion, from your two-wheelers to three-wheelers to four-wheelers to aircraft to ships to satellite, space, everything, your rocket propulsion, and so many things are used for, and this all can be studied by the help of the thermodynamics. So how this steam, how the water was boiled, and this water, how much it is containing the pressure, how much it is volume or specific volume, how much temperature, how much enthalpy, how much entropy, these things, how we can calculate. In my previous classes, we have derived some equations for our quality of the vapor, for the pressure, volume, temperature, PV is equal to MRT. So pressure, volume and temperature relationship. But if it is not the ideal gas, like our steam we cannot take as an ideal gas, because it is in the two phase and they are not in proper equilibrium, a chemical equilibrium, they are not in that. So we cannot use directly all the equations which we have already derived. We need something by which we can directly find out the values of different zones. These type of tables which are prepared by the scholars for the scientists and engineers, and these types of tables, it is not only for the steam, name is a steam table, it can be the air table, it can be the nitrogen table, it can be the refrigerant table, different types of tables are there, and these tables are available in the thermodynamics book in the appendixes, also available in the market. We can buy these books and we can practice in the home. Nowadays we use the computers. If you give the parameters, computer will give automatically the next parameters it will give. But as a student, we should understand how these things have come and how we can make sure that these are working properly and we are getting the exact values what we want as per the requirement. So today I am going to discuss about steam table, and also I am few examples are there that I am going to discuss in this course. So here I will be looking for the introduction to steam table, need of steam tables, numerical solution with the help of steam table. So these are the few topics which I am going to take in today's class. So steam table. What is the steam table? Steam tables are defined as the thermodynamic data that contains the property of water or steam. So only we are discussing here steam table, but there are other tables also, I told you. So steam tables are defined as the thermodynamic data which gives the pressure, I will show specific volume, saturation temperature, and then vapor temperature, all things I will be showing you in due course of time in my next slides. So these data are commonly used by the engineers. It is normally used to obtain the following properties using steam pressure for saturated steam temperature, and for saturated temperature for saturated steam pressure. So if you know the saturated pressure, you can find out the saturated temperature. If you know the saturated temperature, you can find the saturated pressure. It is also widely used for a particularly enthalpy and the specific volume. We can find out different types of properties. How to read steam table, that we should understand very well, and these are the few nomenclature. These nomenclatures are used, standardized all over the internationally. These are accepted nomenclature. So if it is P stands for the pressure of the steam or water. T is the saturation point of steam and the water. Vg is a specific volume of saturated steam. Vg, you understand that it is for the steam, and Vf is specific volume of saturated water. Hf is a specific enthalpy for saturated water. Hfg is a latent of evaporation. Means this is the latent heat and it is for evaporation. And Hg is a specific enthalpy of saturated steam. So here we can see that the small letters like this V, H, they are the specific quantities. These are the small letters. They are the specific quantities. So if I write G is for the steam, small, and F is for water. Small f, the subscript Vg, Vf, F is for the water, G is for the vapor, here also G for the vapor. So this we have to understand very well, and they are specific volume. Means if you want the V is equal to total volume divided by mass. If you want small h, this specific enthalpy is equal to total enthalpy divided by mass. This we have to take care of. That steam table will give the specific, means it is divided by mass. That much we have to ensure. So if you get the V and you want to find out the total volume, you have to multiply it by V, M. So V is equal to small v into M. H is equal to M into H. So like this we have to find out, and we have to see that these things are very much taken care of. Now this is the saturated steam table which I am going to discuss about. In saturation steam table, the temperature and the pressure of the saturated steams are mutually dependent. Means saturated steam table, the temperature and the pressure of the saturated steams are dependent. Means P and T both are dependent. I will discuss in detail in, I think, next slide. When one of them is given, if P is given, the T can be determined. T can be determined. These tables usually include other related values such as specific enthalpy H and the specific volume V. So if you know this PET, you can find out the enthalpy H, specific volume V, and so on. That we will be discussing in these tables. So here superheated steam tables are shown. So what is the meaning of the superheated? So we should understand that if we take a here in this diagram, if you see, here is you see this diagram. Here it is a plot of T versus specific volume V. T is in degree centigrade and this is in meter cube. So if you see this 1, 2 and the 3. If you see from here to here, it is a compressed liquid region. This is the vapor region and this is the superheated region. This is called superheated region. Okay. So this we have to see here that if we further heat the saturated steam after a boiling point. So this is what? This is the boiling point. And if you read further here, at given constant pressure, then it will convert to superheated steam. So from here onwards, from here, and from here, this becomes the superheated steam. The additional heat and the degree of the temperature are applied to steam above the saturation point is known the degree of the superheat. If suppose this is the 100 and here you have the 400. So 400 minus 100 is equal to 300 is the degree of superheat. And this you can find out from the steam table. If you see here, I have shown here the steam table of the temperature at degree centigrade, pressure in bars, it is mentioned here, specific volume, meter cube per kg, internal energy, that is U. So Vf is a liquid. This is what? It is a liquid and this is the vapor. So if you see at 10 degrees centigrade, the pressure is this, you have Vf is equal to this and you have Vg is equal to this. So what is the Vf? Vf is this one, Vf, and this is the Vg. At this point is Vg. So this you can find out at 10 degree or any temperature and at any pressure you can find out the Vf and the Vg. Same way here you will have the Uf, internal energy in this, and you have the Ug. You can find out the internal energy in kilojoule per kg. This is also a small letter. So this is the specific internal energy. So by this type of plot, you can find out the values which are very much essential for calculating the different thermodynamic characteristics, thermodynamics properties. Next, terms used for steam table. We can see here that we use the saturation temperature. So what is the saturation temperature and what is the saturation pressure? So this saturation temperature for a corresponding pressure at which liquid boils into its vapor phase. That is called the saturation temperature. So if you see here in this table, so this is here saturation temperature and this is the pressure is given. This is here a specific volume and this is here a specific volume of the vapor. So here this you can see that temperature for a corresponding pressure at which liquid boils into its vapor phase. So liquid is become to the vapor. For water it is 100 degrees centigrade is the saturation temperature at 1 atmosphere. At the atmospheric pressure at 100 degrees centigrade, it is called the saturation temperature. What is the saturation pressure? Pressure at which a given liquid and its vapor can coexist in equilibrium at given temperature. So saturation pressure is what? It is the pressure at which the liquid and the vapor can be together at a given temperature. What is the dryness fraction? Dryness fraction is defined as the ratio of the mass of vapor in a mixture to the total mass of the mixture. Means if you have m liquid plus m vapor, so the dryness fraction is the m vapor. How much liquid is there? How much vapors are there in total mass? So it is called the dryness fraction. So dryness fraction X, it is also called the quality of the steam. Another word is quality of steam. So if this X is 100%, then you can say that it is a quality is a 1. So here you can see in this diagram that how these things are working. So here it is a P and V diagram. So here it is a compressed liquid here, and as you increase the volume, pressure has to decrease. Pressure has to decrease, and from here to here it is a saturated. Here your pressure will remain constant. However, volume will increase. As you go further at the saturated vapor, this will also increase. So saturated temperature is here. Here whatever you will get, it is called the saturated temperature. This is called the saturated pressure. And here is the dryness fraction X is equal to 0 and here X is equal to 1. So it is divided into, so if it is here means between X is equal to 0.5. So like this you can find out the quality X or the dryness fraction, and it is defined as the mass of the vapor divided by the total mass, and this total mass is equal to summation of the m liquid plus m vapor. So now I will go for the further description of the steam table, because we all should understand how to read the steam table. So this steam table is the temperature based steam table. So here the 10, 20, 30, 40. So if the temperature you want to find out the 15 degrees centigrade, 25, it is not given. So you have to interpolate. By the interpolation you can find out how much is the different quantity. Okay, so assume at 10 degrees centigrade you have Vf this, Vg this, Uf this, Ug this, enthalpy HF this. At 100 degrees centigrade you have these values. At 150 it is shown in this, but it is from long more temperatures. You can see a very big table is there. From there you can find out. Here it is temperature based, that we have to make sure that whenever we read, we have to see the temperature, and then we have to find out the different other thermodynamic properties. So here I am giving one example how to find out the so here is one example that what is the specific volume of saturated vapor at 40 degrees centigrade. So how to find this is, first we have to go here. First you have to see here at 40 degrees centigrade in the temperature, and then you have to find the specific volume at saturated vapor. So you know what is the meaning of saturated vapor? If it is the T and the V, so like this. This is the saturated point. Means it is a Vg. This is a Vf. So we have to find out Vg at 40 degrees centigrade. So here is Vg is what? 19.515. So 19.515 meter cube per kg. So like this, if you want to find out the saturated vapor and saturated liquid. So if you want to find out the specific volume of saturated liquid, so it is a Vf. So how much is the Vf? we can see that Vf is equal to here. This is the Vf here. This Vf is equal to, if you want to find Vf is equal to 0.00100079. So like this you can find out how much is required. Now the next, if you want to what is the enthalpy of the saturated liquid at 120 degrees centigrade? So enthalpy of the liquid we have to find out, means HF. So if you see here 120 and then we have to go HF, and you will get 503.81 kilojoule per kg. But if you want to, I give the question, what is the enthalpy of saturated vapor at 120 degrees centigrade? So how you will find out? First you have to go to 120 degrees centigrade and go in this line straight and then go to Hg. You have to find now Hg. So how much is the Hg? Hg is 2705.9, and you have to put this value of unit kilojoule per kg. This you have to put. This is the answer. Same way you can find out the internal energy. If suppose you want to find the internal energy of saturated liquid at 80 degrees centigrade. So what I have to do? Saturated liquid of 80 degrees. So first I have to go to 80 degrees centigrade here. Then liquid. This is the liquid HF. So I will go from here to here in this line, in this line, in this line, and this is the liquid. You have 334.96. Answer is 334.96 kilojoule per kg. So like this, any parameters you can find out. It is very easy to find these all numbers. Now I will give some other example how to find out the quality or the specific volume for a different cases. So rigid tank contains 10 kg of water at 60 degrees centigrade. If 7 kg of water is in liquid form and remaining in its vapor form, determine volume of the tank. Very, very interesting. So how to find this all things? So total mass, what is the given here? Total mass is given as a 10 kg here, and liquid MF is given the 7 kg. So how much is the vapor or gas? 10 minus 3, 7 is equal to 3 kg. So mass of the gases is given 3 kg. Mass of the liquid is now 7 kg. So what is the X? Mass of the gas divided by total mass. So mass of the gas is 3 divided by 10. So we got X is equal to 0.3. So from here we can also find out the volume is how much. We know that V is equal to Vf. Okay, just you see here. I am just writing here this. So this is the Vf and this is the Vg. So if you are here at 0.3 we got here, na? So we have to find out how much is the volume. So this V is equal to Vf plus X Vfg. So how much Vf? From this table at 60 degrees centigrade, if you see, we can get Vf is equal to 7.6672. This is the Vf is equal to 0.01017 and Vg is equal to 7.66. So Vfg is equal to 7.6672 minus Vf. So you will get Vfg is equal to this. So volume of the tank will be, you just put this value here. So volume of the tank V is equal to Vf is equal to 0.0010171 plus x is equal to 0.3 into Vfg is equal to 7.6661829. You will get answer is equal to 2.300871 meter cube per kg. This is the answer which we can find out by help of like this table. So now I have discussed the table on temperature basis. Now I want to discuss if the pressures are given, with the help of the pressure, how we can find out the different thermodynamic characteristics like specific volume, internal energy, and all other things, how I am going to find out. So here we have the pressure in bar. It is 10, 20, 30, 40, the all things. But if intermediate also you can find out. There is no problem in this. It is very easy to find out in intermediate by extrapolation method. And here is the temperature. And here is Vf. It is specific volume of the liquid, specific volume of the liquid, and specific volume of the vapor. Here internal energy of the liquid, internal energy of the vapor, enthalpy of the liquid, and enthalpy of the vapor. So at given pressure, suppose it is a 20, you can go here, you can find out this, and this. Anything you can find out if you know the pressure. Now some small practice session is here. What is the internal energy of saturated liquid at 80 bar pressure, and what is saturation temperature? So we have to internal energy we have to find out at 80 degrees centigrade. So at 80 bar, this is in bar, we have to find out the saturation internal energy of saturation liquid. So here this you can see this is the liquid and this is the vapor. So in this we have find out that it is 1303.2 kilojoule per kg. So this is one question which we have done. And what is the saturation temperature? So if you see, the saturation temperature is this 295.01. Okay, so we can get the temperature how much? 295.01 degrees centigrade. Okay, this is the second answer. Okay, so next we have to see the here the for the determine the specific enthalpy of water at a state of P is Pascal 0.01 megapascal at 400 degree centigrade. So in this it is a for saturated superheated condition. So in this two parameters are required. For superheated case 0.01 pressure and the temperature is required. So at 400 degree centigrade and at you are getting 3280 at 0.01 megapascal. Okay, at this pressure and at this temperature you have to go in this line, you have to say you will get the value 3280 kilojoule per. So for the superheated steam, for a certain amount of pressure you have to see, but if it is in the saturated region, you have to only one is required, another is automatically constant. So in this way you can find out. So here this you can see that for this you have saturation temperature, and for the different 0.01 megapascal, 0.1 megapascal at this degrees centigrade. So all these parameters are given in the steam table, and this you can find out by help of this. So how we can interpolate? We should understand that how we can get the interpolation. Like temperature is 300 degrees centigrade and 400 degrees centigrade. You will get the specific volume. You got the 26.446, and at 400 you have got the 31.063, and it is given as a 30. So how you can find out the x? So A is here. We have to specific volume and the temperature plot. A is given 26.449. This you have got. And at 300 degrees centigrade, this you got this point. At the B, you got 400 degrees centigrade. This is the 400, and you got 31.063. So at this, what will be the temperature? This we have to find out. So how you can find out? It is called the extrapolation. So you will get here A is given, B is given, and you can find out the C, and this point, that is the C point, you can find out by the linear line. Means if it is YB minus YA divided by YC minus YA is equal to XB minus XA divided by XC minus XA. So here this you can put the values, and this you will get XC is equal to, you will get some value. In this way you can find out. So I can write here X value is, Y is this. So 31.063 minus YA is a 26.446 divided by YC, we have to C is 30. It is given 30 minus 26.446. So you will get some value, and for this is the YC, and if you want to find the XC, so here this you put the value and you will get all the value. Okay, so in this way we can calculate the exact amount what is the given in that system. So these are the references that I am taking, that Eunice Single, Michael A. Bowles, Thermodynamics and Engineering Approach, Tata McGraw-Hill's 7th edition. Then you can take some NPTEL lectures from Dr. Mishra from IIT Kanpur, Dr. Suman, Dr. Shom. So many NPTEL lectures are available online. You can go, they are very much expert. So you can go and see that. Any questions, you are welcome to ask to my email. My email is ydwivedi@gmail.com. Please do like and subscribe, and also give some comments. So I will be trying to rectify, or I will feel very happy if it is good. Thank you very much for the joining. Please be tuned. In the next class, I will be in the next class some numericals on work and heat. I will be taking. Be tuned. Thank you very much for joining.
Like, share and subscribe. Hit the bell icon for more updates.